How was expansion itself discovered and the Big Bang Theory formulated? I think that's where we need to start to get toward BICEP
Yeah.
and BICEP 2.
So the essence of the Big Bang was really codified over a period of about 12 or 13 years, which is a really short amount of time to have a revolution that upended the, overused term paradigm shift that had prevailed for literally all of humanity, essentially. It believed that the universe was eternal, static, unchanging.
Mm.
So to upend that in a mere 13 years is just astounding. And it was really a combination of the two aspects that you mentioned originally, two of the three aspects of astronomy, which are theoretical and observational, and the third being experimental. That didn't play a role until the later discovery of the cosmic microwave background, which is my expertise, in 1965. So from 1915, when Einstein started to conjugate the laws of general relativity, which would provide a framework for people like Alexander Friedman, and colleagues, as well as this George Lemaitre, who's a Belgian Catholic priest,
Hmm.
to apply mathematically a justification for why the universe couldn't be static. And Einstein actually knew that. Einstein knew the universe was dynamically unstable, and that it could be either it could be expanding or collapsing, but it could only be static if and only if there was an exact repulsive force of gravity to counteract the known amount of matter that he knew about. He didn't know about other galaxies, but he knew our galaxy was made of matter, and he knew we saw light from stars, so there was at least matter and radiation. And matter and radiation are both attractive. Even radiation is an attractive component of the universe's energy. So he, and as a consequence of general relativity, which he had devised over 5 to 7 years, he realized that the universe model in his conception, 1917 or so, was unstable, and he had to stabilize it. He added in a term which is essentially a vacuum energy term, a term that meant the universe was suffused with an energy, unseen energy, effectively what we call dark energy today, that didn't interact with matter or radiation, and provided a negative repulsive gravitational force to suspend the stars in their place. And again, he didn't know about external galaxies that we'll talk about in just a bit. And you mentioned it with respect to Hubble, but that was only discovered in 1923 that Andromeda was an external galaxy, not a nebula within the Milky Way. So Einstein's conception was that the universe was static based on observation. It sure looks static. In fact, I pointed this out to Joe Rogan, and I pointed out many other instances. But the fact that we only had five things that people talked about as movers, and that term, and the etymology is planet, which I also realized recently. One of my kids pointed out, well, plane is just the word planet without a T. I was like, what is a plane? Like, why do they call it a plane? That flies you through the air. But it's really based on planet, which means wander or mover,
Huh.
and in Greek. So the etymology of that word is Greek. So the fact that the ancients named these five things, they could see Mercury, Venus, Mars, Jupiter, and Saturn. They named those things planets, meant that those weren't things that weren't moving. So basically, everything they knew was static except for these five objects. So that was very puzzling. And so what ended up happening was Einstein said, let me take the data, I'll fit it to my model. Oh, I need this bizarre term called dark energy. And reportedly, George Gamow later said that he called that his biggest blunder. We actually can't find any written literature where Einstein says that himself. Putting in of the cosmological vacuum term was my biggest blunder, but it's generally accepted that he did that. I point out many times that because in 1997, two groups of colleagues and friends of mine that have been on the podcast, my Into the Impossible podcast, many times, they discovered that there is a form of dark energy that does pervade the universe, and it may be a cosmological constant, just like Einstein said. So the biggest blunder that Einstein made was rescinding his prediction of the cosmological constant. And he did so, I always joke, if he hadn't done so, he could have had a quite astounding career.
Hmm. How did all of this go back, though, to George Lemaitre, who you mentioned, and his primeval atom model for how the universe began, which I think is the predecessor or precursor of the Big Bang.
Yeah. So in 1927 through 1932, Lemaitre worked on this model of a consequence of Einstein's general relativity, showing that the universe, if it had matter in it, would be unstable. And if you didn't have this cosmological constant, for which there was no evidence until the 1990s, so based on what they knew back then, there was no evidence to support this. And even by 1927, there started to accumulate a great deal of evidence that there were other wanderers in the night sky. And these included what were formerly called spiral nebulae, which were thought to be part of the Milky Way galaxy until 1923, until Hubble discovered what's called a Cepheid variable in the galaxy that we now call Andromeda, but it used to be called the Great Spiral Nebula in the constellation Andromeda. They thought it was just in the Milky Way galaxy. Then they realized it was far outside the boundary of the Milky Way, so it had to be external to the Milky Way, and they called it an island universe. So you have to put yourself in the mindset of the person in the early 1920s. You've gone 1,900 years thinking that the universe was static, and it only had 5 things that moved in it. Now you realize that not only is the universe not our solar system, it's not even our galaxy. And so they called other galaxies island universes. So once this was discovered, it was then discovered that the Andromeda galaxy wasn't the only one of these nebula. And a scientist by the name of Vesto Slipher, I'd love to know the
Great
origin
name.
of Vesto. Yes, that's right. So good old Vesto, he and colleagues made a survey of these spiral nebulae. And they actually did this before 1923. So they didn't know what these things were, that they were external to the Milky Way's boundary. And Vesto observed that about 19 of 24 or 25 of these nebulae had a peculiar property, that they had observed in them stars, and every star is an incandescent glowing nuclear ball of fusion. And that glowing ball of nuclear fusion has characteristic spectral lines, the chemical fingerprint bespeaking of its composition. So stars are mostly made of hydrogen. They fuse hydrogen to make helium. That's where we get the term helium from. It means sun. And that's because it was discovered not on Earth, but it was discovered on the sun. I don't know if you knew that, but helium was discovered on the sun. Yeah. So they had to go at night to observe it. So helium was first observed, and then it has characteristic spectral lines indicative of the electronic transport within the atom. And that's driven by photoelectric interactions and quantum mechanical processes. But it can be used to make a chemical fingerprint, and that chemical fingerprint had a different behavior depending on this particular galaxy's distance from the Milky Way. They all, with the exception of about 5 of them, they all showed a characteristic fingerprint. So if you're listening, I'm holding up my hand. They all showed it shifted to longer wavelengths or lower frequencies. That's called a redshift. And it's just the same phenomenon that you'll hear when an ambulance is moving away from you. You'll hear the pitch of its sirens decreasing. And that decreasing pitch then makes a characteristic imprint that can be used since Doppler's time in the 1700s to measure the velocity, the recessional velocity of an ambulance, of a train, or of a galaxy. Except with the galaxy, its velocity is measured relative to the speed of light, and for objects on Earth, it's relative to the speed of sound. So for the speed of light, these galaxies were receding at tremendous velocities. They were receding at fractions of the speed of light, which is incredible, with a handful of exceptions. There are about 5 out of the 23 or 24 sample size that he measured, that Lemaitre measured, that Vesto Slipher measured. And then what Hubble did was synthesize the data of Slipher, showing recessional velocity, v. And then Hubble correlated that to distance measurements, which he knew how to do, courtesy of one of the most unsung heroes of astronomy named Henrietta Swan Leavitt, who'd come up with a measuring tool to use the brightness of a variable star as an indicator proxy for its distance. And that's what Hubble put together. and made a very simple but extremely bold plot that showed velocity as a linear function of distance away from the Milky Way. And like I said, there was only one or five handful of these galaxies out of, more than 24 that showed a blue shift. In other words, they were coming towards us or they were static with respect to us. And of course, in later years, we've measured, the spectra of hundreds of millions of these objects, and all of them, except for those same original, 5 or 10, are moving away from us. So from this conclusion, Hubble and Slipher and Lemaitre began to draw a picture that the only way that this could happen, there are two ways this could happen. The Milky Way was indeed the center of the universe, and everything was moving away from us as if we had, some kind of cosmic body odor dysfunction. There was some problem with us, or that every galaxy is moving away from every other galaxy in an expanding four-dimensional space-time. And it could have been that they were collapsing towards us or coming towards us, with a handful of exceptions perhaps, or it could have been that they were moving away from us, but it certainly wasn't the case that they were static. And faced with this, in 1927, when Lemaitre came up with this, again, there was only a very small set of data. By that time, Einstein rejected this notion of Lemaitre. He said famously, your math is correct, or your math may be correct, but your physics is atrocious. Meaning that how could you have an expanding universe? The implication was that if you ran the clock backwards in time enough, we would be touching not only these 24 galaxies, but we'd touch every single galaxy in the universe, and all the matter in the universe would be concentrated in one spot, which is what Lemaitre called the primeval atom. He ascribed the observed amount of galaxies, he converted them to a typical mass, and he said if all of their mass was once in a certain compact region of space-time, they would only fill up a volume equal to a sphere of the diameter of our solar system. And they would have nuclear density at that point, and maybe even greater than nuclear density. So they would have atomic nuclear density. That's what he called the primeval atom. He realized that was unstable, that would explode. Nowadays, we don't view that as the correct picture, but there is still no certainty as to how that picture arose in the first place. So that was the primeval atom. Einstein rejected it until 1929. By 1929, Hubble had plotted his famous law. And by the 1930s, Einstein visited Hubble down here in Southern California, Mount Wilson, and was convinced that he had made a mistake in assuming that the universe was static. And actually, so therefore, his model of a static universe was disproven by observational data, acquired by telescopes built by instrumental builders, experimentalists, and but it wasn't that the Big Bang was proven. In fact, we still don't know if the Big Bang is proven in the conceptualization that Lemaitre had. So that shows you what we do as physicists. We don't prove, we falsify. And so Einstein's static universe model was clearly falsified. And then that brought in, as typically happens in science, as you know, once you patch flaws in an existing paradigm, new flaws and new cracks emerge. And later on, we'll get into inflation, and inflation purports to patch many of those lacunae in the original Big Bang model.